Basically, welcome to the StarkNet Layer 1, Layer 2 Messaging Workshop. Um, our last workshop for the StarkNet Hackathon, which is really sad. It's been brilliant so far. And yeah, welcome to everyone from around the world. Awesome to have you here. In Code, obviously, is always happy to just be a community for a worldwide basically community, which is really cool. And I had quite a few one-on-one calls this week with hackers. I'm sure some of you, and we've had some awesome projects being built, which is really cool. Yeah, so please keep booking one-on-one calls with me, especially over the next couple of weeks while you're hacking. I'd love to hear about your projects. There's some awesome projects out there which we're really excited about. And obviously we've missed Henri, haven't had him on the workshop or the event for the last 2 weeks. So it's lovely to have Henri back as well.
Thanks for the introduction, and thank you to everyone for being here again today. And thank you for this fourth session. I wasn't there last time. I heard it was great, and that you guys learned how to build a cool front end on top of your on your apps. So that's great. I'm really excited about today's workshop for two reasons. The first one is that I'm going to be presenting a really cool brick. Up until now, we had seen things that you could do on Ethereum, but couldn't really do on, but that you could do on Ethereum and you could do on L2. Now, I'm going to show you something that is unique to StarkNet. So that's the first reason. The second reason is that just as the ERC20 workshop that we did last week, I did not write this workshop and this tutorial. It was written by a member of our community, Othman, who will be here to present it. And I'm excited because it's always fun to collaborate and to have people from the ecosystem get involved and help us teach. So without further ado, let's talk bridges. So what are bridges? Anyway, you guys are used to using bridges. I imagine some of you have used bridges to move liquidity from Ethereum to maybe another sidechain, to Polygon, to Gnosis chain, maybe to BSC, or maybe you've moved them to other L2s like Arbitrum Optimism. But what is it that you used? What is it that you moved exactly? You moved probably assets. And most likely you moved tokens, ERC20s or ERC721. You moved, you used one of those bridges, so maybe Wormhole, Connect, Up, and really what you did is bridging ERC20s to, or NFTs to from L1 to L2, which is a great tool. It's fun, but like, is it all you can do? Just the same way that on L1, you can do way more than just creating tokens or trading them. Is there more you could do with a bridge? You could do bridges to do a lot more things. Actually, you know, you could have you could bridge permission. You could have a bridge, a dedicated bridge, to have permission set on one chain, transfer to another chain, so to enact some kind of action. You could bridge computation. So, you know, we mentioned that on L2 on StarkNet, computation is cheap. So you could do some computation on StarkNet and then bridge it back to L1. That could be nice. You could bridge instructions maybe to mint or unmint NFTs. So, you know, why do we build? Why is there just money bridges? Wouldn't it be possible for a chain to have more kind of bridges? Or just maybe we could have less bridges. We could just have one simple bridges that passes data instead of passing assets. And then we just leave people building their own bridges. You know, I mean, it's one thing to say, hey, here's how you communicate and you send assets, or how you send instructions between our chain and Ethereum. But really, if you dive deep down into that, really, you just need to pass data. You just need to pass instructions. And so that's the route that we decided to take with StarkNet. And what the brick I'm going to show you today is really something not to pass. It's not application specific. It lets you transfer data, and you can do from that data whatever you want. You can consider them as instructions and payload. Xan is asking, can tokens be issued on the L2 without bridging from L1? And Xan, the short answer is yes, it is possible. I think I've said everything in these 3 slides, but it takes diving into the way it works to actually fully understand how it works. But basically, it's up to you, Xan. If you want your bridge, your token, to be living on L1 and just wait for L2 messages to mint your token, you can. In fact, I think that's one of the first applications that we'll see because they're simple to implement. But basically, you'll have an asset that fully lives on L2, that is emitted and exchanged and has most of its life on L2, and that has some kind of bridge to L1 that guarantees that you can have always a safe way back to L1 without actually, for most tokens, being minted on L1. It's kind of what Immutable and Sora are doing right now, actually. And Peter is saying, it sounds very similar to Polkadot's ECM. I'm not familiar with it, but yes, maybe it's possible. That being said, and we'll go back to that later, what is really cool with that is that the bridge is not guaranteed by game theory. It's not guaranteed by validators passing messages. It's guaranteed by math. So the assumption and the underlying principle is much stronger because it's mathematical guarantees instead of game theoretic ones. Okay, so let's explore a bit how that bridge works. And let's see first the first step, which is how do you talk to Ethereum? So how do you send a message to Ethereum? Basically, the first step is from your Cairo contract to send a message. And your message is just an arbitrary array of fields. And you're sending this message to a recipient, which is an L1 account. So here you can see these are 2 lines from a contract. So you need to import one specific function design in the StarkNet stack, which is send message to L1. The name is self-explanatory, I guess. And then in this function, you pass a to address. So who do you send this message to? And then you pass an array. So as usual, when you pass an array in Cairo, you need to specify its size, and then you pass the array itself, right? So in this case here, you can see there's an array called message payload, and it has 3 fields. One is the L1 user. So in that case here, we're trying to mint a token on L1, right? So L1 user is the address of the person who will receive the token. Then you receive the amounts. Then you put in the amount. Then here there's a secret value plus 32, kind of the signature of our tutorials. We have hidden values everywhere. But here it's basically a value that you show so to show that you know the answer to this riddle. And that's it. So that's basically how you send a message from a smart contract on StarkNet to L1. Okay, so what happens exactly after that? So once you've sent your message from your smart contract, right? So this is inside a function, and this function is called by whichever way on L2. And so this is triggered, send message to L1. What happens after that? Your message is registered by StarkNet, meaning that StarkNet has registered your message, and you can see it appear in Voyager, and you can see it in your, if you have a full node, you should probably see it. But at least your message is visible in Voyager. If you look at the contract you were interacting with, you can see there is a tab messages. And here in the messages, you can see that there's the 2 L1 messages. So messages from L2 to L1 and messages from L1. Fairly self-explanatory. Important to note is that your message is indexed by its hash, and I'm going to come back later to that. How is this hash calculated exactly? But basically, your message is identified by its hash. If you click on your specific message, you have different informations. And here you have the status of your message. Your message can have four statuses. Sent, so this means that this is right after you sent your transaction and the message was sent. So it means that StarkNet is aware of your message, but not Ethereum. Pending means that the message was transmitted to Ethereum. Ethereum received it, and it sits on L1, waiting to be consumed. And consumed means that the recipient on L1 called the message. You can imagine this way as kind of like a mailbox. So basically, you send your contract sends a message from L2 to L1, and when it is transmitted to Ethereum, Ethereum has a little mailbox with the name of your smart contract, the recipient on it, and the letter is here waiting to be consumed. So technically, how long does this take? Your message will stay in the status sent while it is waiting for a proof to be sent to Ethereum. So this may take some time. As you noticed, proofs from StarkNet testnet are currently emitted about every 2 hours. So your message, before being sent to L1, actually sent, will take up to 2 hours. Now, pending, how long do they stay pending? It's up to you. They can stay pending for a long time because retrieving the message from L1 is an action that needs to be triggered by the contract. So yeah, I'm gonna come back to that later. Okay, open and then Florian is asking, can we choose the content and the length of the message? Yes, going back to that function here. See, there's nothing restraining you in message payload to have an array that is of shorter or longer length. The only constraint that you have is that it's a felt array, but you can pass any kind of data there. Okay, so if you want to mint a token, you can send the ID of the token, the recipient, whatever you feel is appropriate. That's what's really interesting with this bridge is that since you're passing data, you can come up with your own protocol. You can come up with your way of having L2 and L1 talk. I think it's actually a really interesting area of standardization. I think it's in the coming years, we'll probably see a lot of standardization efforts around cross-chain communication and how we define messages for chains to talk with each other. So Antoine is asking 2 questions. Is there some sort of standard for the payload? No, not yet. For instance, at index 0, no, there's no standard right now around that. I think it's a fascinating area of standardization, and but I think it's a bit too soon. Once we'll see applications emerging, we'll see standards emerge. But I know that Fran from Open Zeppelin is actually involved in that reflection. Like he's posting stuff about that. Marwan is asking, is the secret value required for every message? No, this is just a specific example that you'll see on the tutorial. Basically, the tutorial will do, I'll come back to the tutorial today, but there's no secret value required for every message. Now, Anton is asking, who pays the fee on L1 if my message executes some smart contract function? Your message does not execute some smart contract function. It sits in the mailbox and it is waiting to be consumed. That's one key thing here that is important. L2 to L1 messages will sit indefinitely in the mailbox, right? And it needs to be, you need to trigger something on the recipient so that the recipient consumes it. The other way around, it's different. Now, Xan is asking, who pays the fee for messages that are consumed on L1? Is it the user on L2? Okay, same question. So the user on L2 will pay a message. Okay, let me move a bit forward in the presentation because this will clear some doubts. And Philip is asking, the price is for how many bytes I send to L1. If I send a Boolean value represented by a felt, I pay for the full felt? Yes. you do. Now, if you're sending a Boolean value or a bunch of Boolean value, there's nothing preventing you from encoding a bunch of Boolean value into a single felt. That's why I mentioned that you can design your own protocol, and with a single value, you can do a bunch of stuff. Okay, so what is happening exactly when you're sending a message? Your message is sent when there's a state update on Ethereum. So what is happening is that the payload of your message is actually sent to Ethereum and concatenated to generate a hash for your message. The content of your message is not stored in the state of Ethereum, but its hash is. And you can, however, find the content of your message if you look at events, because the content of your message is in an event. So if you're familiar with Ethereum, you know that events are often used like that. They're used to log data that may be useful in the future, but that you don't need actually in the state. In that case here, we chose to do that. You'll see later that you'll have to pop back the content of the message in order to consume it. But we chose to do that for two reasons. We don't want to burden the state of the StarkNet contract on Ethereum with all the payloads, but we want the payload to be constructed back. Okay. So once your message has been logged on Ethereum, it is indexed by its hash again, and it has a counters. Basically, in the StarkNet contract, there is a mapping with I think as an index, it has the recipient, so the contract that can consume a message. Then it has a byte 32, which is the hash of the message, and then it has a int, which is the number of messages. Because your payload can be duplicated. You can send various times the same message. And so there's an int counter that tracks however many messages are there. So at this point, your message is sitting in the mailbox. The hash of your message is registered on Ethereum. What happens next? The message is consumed by the L1 recipient, meaning that your smart contract on L1 needs to call this function, consume a message from L2 on the StarkNet contract, right? And so you need to say, hey, I want to consume that message. You need to send the full payload of the message. You can't just send its hash, right? And so you specify who's the contract that sent it on L2, and then it will hash. So that's how the hash of your message is calculated, right? It's a concatenation of the sender address on L2. So the smart contract that used the function send message to L1, concatenated with the recipient address. So here it's the decimal version of the address that is consuming the message. Then the length of the payload and the actual payload. Here you can see on line 143, it checks that the message exists, meaning that there was something that was received. And if it was received, it emits a message to track that this message was consumed, and it decrements the counter by 1. Okay? And it returns the message hash. Is that clear? So that's the way, basically, that's pretty much all there is to it. It's not that complicated, right? But if you follow along, this is extremely powerful because you can basically send any kind of arbitrary data there. So something important to note is that messages are transmitted with proof, meaning that there are delays. It takes some time. One way you need to think about that, it's kind of like the what is called the Othman windows. I'm not sure if you're familiar with the term, but basically I think it's every 22 months or so, Earth and Mars, the planet, come closer. You know, they have different orbits and different time to orbit around the sun. And basically, at some point, you know, Mars is on one side of the sun and Earth is on the other side of the sun. And at some point, they run next to each other. The Othman window is basically the window of time when Earth and Mars are very close to each other. And that's when you send your message. So, and this implies a lot of things when you think about dynamics between the two planets. because that's when you can send food supply or anyway, it's an important concept in the way you manipulate a transplanetary circulation. And the fact that there is a 2 hours delay, or at least a delay between your transaction and the proof being sent to L1, needs that you need to think about that when you're sending your messages. This also means that if you fuck up your L1 to L2 messages, this will take a long time for you to debug. So take care of that. However, right now this frequency is fairly slow. Once usage on StarkNet picks up, you'll see this window of time probably be lowered. Okay, I see there are a bunch of questions. Let me see that. Let me see them. Okay, so going back to the question of Xan, who pays the fee for the message that are consumed to L1? So I think the question here is like, how much does this cost? So here, the cost of sending a message for the person updating the state on Ethereum, which is currently Starkware, but one day will be the prover or the sequencer, is that you are changing the storage of a Uwin-256. You're basically here storing a message hash and you're incrementing a storage. So this has a cost. And so the cost of sending a message is the cost of storing one thing. There's also the cost associated with cold data, but it's not necessarily stored on chain, right? It's passed as the event. So the cost of sending a message is this. It's a function of how long your message is and the slot you're using. Right now, the way it is built on StarkNet, I think we only take into account the fact that we're storing one slot. We don't take into account the message length yet, though that may come with time. And we don't take into account the triggering of the function on the other side, because that's your responsibility. Basically, you need to find a way to trigger the smart contract on the other end that that will consume the message. That's why I'm in here. This triggers. Oh, no, it's not here. I didn't include it. Okay. Yeah, no, it's here. Trigger can be arbitrary. Basically, you can set up your application however you want. You can use a keeper network. You can gatekeep the message consuming function, or you can leave it open so that anyone can trigger it. But it's on your end to decide what's the logic around that. And then Florian is asking, in consume message from L2 is from the contract address on L2 or the StarkNet contract. So from address is the L2 smart contract address that used send message to L1. Same question by Antoine. Florian is saying, I really look forward to a plugin for Truffle. I don't want to wait for planets to align. Yeah, I agree with you right now. So if you've done the previous tutorial, you know, I guess, that Cairo is not that difficult, not that easy, but not that difficult either. That what makes it a challenging process here on StarkNet is that tooling is still nascent and it's rough around the edges. It has a few bugs and so on. If you were here on Ethereum 4 years ago, it should look familiar because that's the way it was. And right now, aside from just writing smart contract and compiling them, we have this extra difficulty of saying like, hey, we can have a devnet locally when we develop, and just that right now is even a challenge. How do we debug and code around L1 to L2 interactions? And you're absolutely right, Florian. It does take a lot of time, and it's hard to debug. So I really look forward to tooling being better around that. That's actually a very good idea for the hackathon. If you guys want to develop a tool where I can have on my machine both the devnet and Ganache running, and you have some kind of way where the devnet will do something to Ganache, and you can use both Ganache and devnet to communicate with each other to simulate L1 to L2 communication, that would be wonderful. And I'm pretty sure that's something you can do. Yeah, I'm pretty sure that's something you can do. Maybe you could. Anyway, if you're interested in doing that, let's talk, because I think you can do some something cool. Mira is asking, will the bridge be permissioned? If so, how are allowed token data chosen? So Mira, there are two questions here. Your question is tokens or data. So regarding data, no, nothing is permissioned. You can use the bridge to transmit any kind of data you're interested in. We don't monitor that. That being said, what you're saying here is, oh, but there will be a bridge for tokens, right? And yes and no. You can build your own bridge, so you don't have to use one specific bridge. That being said, if everyone uses a different bridge to bridge USDCs to StarkNet, then we'll have a bunch of tokens on StarkNet that are all USDC, and that might be confusing. So we know that we need a shelling point. We need one bridge where most of the liquidity will be accrued, and we're working on that. So we will operate this bridge that will allow you to transfer arbitrary token. Right now, we are in the process of choosing which token will allow. Don't know if I have specific guidelines I can share around that. But I'll also mention that while it makes sense for us to operate certain bridges, certain teams are also saying, hey, we're happy with operating our own bridge. And for example, the Maker team is currently working on the DAI bridge. So our token bridge will not include DAI because Maker will operate their own bridge. And they're actually looking at using the bridge to actually mint tokens on L2 that are secured by L1 liquidity. But I'll go back to that. Can messages be sent to testnets, or is it only for mainnet? You can send messages to testnet, absolutely. Today's tutorial will be exclusively on mainnet. And yeah, by the way, we have a tutorial at the end of this session. As usual, we're gonna present it quickly, but you have some hours of fun ahead of you. So make sure you complete it, and you'll learn a lot of stuff. So Antoine is asking now, if I have to manually trigger my function on L1 and pay the tax fee, isn't DeFi pooling, where the user only interacts with L2 with a low fees, high speed, quite a myth? I mean, it seems I can't simply say on L2, deposit my money on that L1 vault without doing anything on L1. That's an intricate question. I would say the following. If you've ever deposited money on Yearn, so for those who are not familiar with Yearn, it's a DeFi aggregator. And basically, it allows you to follow some strategies where you will deposit some, where you take advantage of farming to sell, to farm a specific token. So imagine you have USDCs, and a system allows you to gain yield on USDC and distribute you their own token. What a lot of people do is that they receive the yield in USDC, then they sell the tokens and buy more USDC with it, right? But this is expensive. You need to do a transaction each time you do that. So what Yearns offer is a system where you give them your USDC and they automate this and they do it for you. It's kind of the same thing, right? I mean, like, you do it once and then a process takes care of it. It's sort of crowdsourced. It can be delegated. It can be permissionless. It's really up to you on how you define it. I don't think DeFi pooling is a myth. I think there is one transaction that you won't be able to get rid of, which is the approved transaction. So imagine you have a DeFi pooling contract, and you want to deposit liquidity on L1 to that contract. Then you'll be able to basically say, okay, I send one transaction to L1 and I approve the DeFi pooling contract to take my liquidity. Then you get credited something on L2, which waits for your deposit to be processed. And every 8 hours, every 24 hours, I don't know, it depends on the way DeFi pooling is implemented, message is sent from L2 saying, hey, here are all the users that deposited money in the system and I've pre-approved you to take their tokens. Then with a single transaction, you can say, okay, go take money on all of these accounts. And with a single transaction, you will be able to take all of the money of all of these people. And this transaction is basically shared. The cost of this transaction is shared among all users. And the protocol can decide how they bill for it, right? And then what you have essentially is a bridge where instead of sitting in a smart contract doing nothing, the liquidity is in a L1 pool. So that fundamentally changes the nature of your bridge. Think about it. Your money right now, when you're sending it to Polygon, it sits on a contract doing nothing. It's just there. With this kind of mechanism, you could design your own custom bridge where the liquidity sits in Aave or in Yearn or in whatever system you want, right? And Antoine, you say, maybe I just didn't understand DeFi pooling properly. I think DeFi pooling is an emergent system. It's a concept that is not very well defined, and the reason why we haven't seen an application currently implementing DeFi pooling is that it's fuzzy. Everything is to be built in that regard. I'll go back to that later, but thanks to the StarkNet bridge, you can tap into any liquidity on L1 from L2. So I'll repeat that. Liquidity on L1 can be used on L2 on StarkNet. This means that basically the availability, the liquidity available to you on L2 is the same as the one that is available on L1. And the pools that you have access to on L2 are the same that you can use on L1. You know, you don't have to worry about, hey, the rates on this DeFi system I like on L2 is not as good as the one on L1. You can tap directly into it. So that's, I think that's pretty cool. Okay, so we've talked about sending messages to L1 from StarkNet. Now, how does it work the other way around? Well, it's sort of the same thing. It's same, but different. Basically, the way you send a message is you use a function in your smart contract. The difference here is that in your L2 contract, you use a native function of the OS. Here, in your smart contract on L1, you're going to use a function of the StarkNet smart verifier smart contract that is deployed on L1. So you're going to use this function, which is send message to L2. So your smart contract on L1 will say, hey, do something. And it will say specify who is the recipient of that message. It will specify a selector, which is basically the function it wants to call, and then it will specify a payload. The big difference between L1 to L2 and L2 to L1 is that when you go from L2 to L1, the message is posted on L1 and is waiting to be consumed. On L2, the message is sent to L2 and immediately posted to the L2 smart contract. There is a specific kind of functions called L1 handlers. You can see here a decorator, line 120, which means this function is not an external function. You can't call it from another contract, but it can be called when there is a message coming from L1. And it is immediately executed. So L2 to L1 messages are much faster because we just wait for 10 confirmations on Ethereum before putting them into StarkNet, and it calls immediately the function. That's like, it doesn't sound like a big difference, but it kind of is, because it means that the cinematic around message consumption is a bit different, and it also means that L1 to L2 messages are super finicky to debug. Because imagine that you messed up your message here when you sent it to L1. It will take some time for the message to be transferred, but when you execute your transaction, you can see immediately that it failed there, and you can understand where your error came from. Here, the message is executed immediately, and you can't really know why it wasn't executed correctly. It's very hard to debug, and that's something we need to make better. So same as before, these are new tools, new capacities, and we're still trying to figure out how to make the developer experience around that better. If you have examples or ideas of things we could do to make it better, I'm all ears. I want to know your opinion on how we can make your life easier. Okay, so Peter is asking, so user can stake on the L1 Bancor as an example via the bridge. Yes, actually, you could have a wallet sitting on L1 that holds token, and you can send instructions to it from L2. So you could have an application where the muscle, the liquidity is on L1, and the brain, the governance, the decision-making is on L2. You get people coordinating, doing stuff. You could have a DAO treasury where you get people to vote on where to allocate assets, and all of this happens on L2. And it is much cheaper, and you can do a lot of things in decision-making. You can implement whatever voting procedure you like. And once a decision has been made and has been reached, you send a message to L1, and just with this single interaction, funds get allocated where required. By the way, these contracts that I picked here, this is a contract from the workshop, and this is a contract from StarkNet Core. So I'm going to show you how to find these because they're fairly important. We're going to, or maybe Othman will later on. So Peter is saying, wow, yeah, I got the same reaction when I thought about it. I thought like, hey, this is a really cool tool. It's really versatile. It really allows you to, I mean, this brick here is really what makes StarkNet an extension to Ethereum rather than a separate chain. It allows you really to leverage things you have on L1 from L2. It allows you to build upon what already exists on L1 from L2. Sure, there is some delay. There are some things to think around, and the tooling is nascent, but it is extremely powerful, and you can build a whole class of super cool applications with that. So why is this cool? So the first thing I wanted to mention, so I don't know how Polkadot works, but why is this different than communication you could have on proof of stake chains talking with one another, or than proof of authority chains operating a bridge? It's fundamentally different because when you send a message from L2 to L1 with StarkNet, this message is part of the state of StarkNet, and Ethereum is able to tell that. So when you say, hey, StarkNet move from block N to block N plus X, and here's the state difference, part of this will include messages, and Ethereum will be able to check like, oh yeah, these were the messages that were sent. And so basically, Ethereum has mathematical proof that the message was sent. It does not rely on the honesty of validator. It does not rely on them losing their stake. It's really like them natively talking. Ethereum understands what happened on StarkNet and understands that a message was sent to it. That's why I put this image. It's kind of like aliens talking with each other. So that's cool because it's really, I mean, it's the first example I have of really blockchains talking natively and understanding each other. That's anyway, I find it fascinating. And then the second thing why this is cool is that you get to build your own bridge. You don't have to use ours. You can decide to use ours. You can decide to build your own bridge to transfer token. You can decide to build your own NFT bridge. You can decide to, as someone asked earlier, you can decide to mint your token on L2 and just have a bridge that say, hey, this is a way if you want to mint your token on L1, you can mint each token only once on L1 and then bridge it back if you want. But here you have a bridge where you have a safe way back to OpenSea. So I think that's actually a super cool use case. It sounds basic, but basically, if you want to make an NFT drop, you get two kind of people involved: speculators and people who are in your community. And everyone kind of wants the ability to sell on OpenSea if the NFT takes value, but it's especially important for a speculator. And it's cool if you can sell a bit of your NFTs to them, because it's cool to make a living and earn some money. But some part of your community will also be happy to just have the NFT and maybe play with it, or maybe you can think of cool things to do with your NFT. And then your issue here is that you can't do all of that on L1, because minting NFTs on L1 will be extremely expensive. So your community will just have to take the hit of the gas cost, and you can't really implement cool stuff on L1 because it's expensive. So the scope of things you can imagine and games you can imagine with your NFT is fairly little. With that tool, you can design a very simple bridge that will let you mint the NFT on L2, and you can build your game on top of it. You can have some very fun stuff. And if people want to keep the NFT and have fun with it, they can stay on L2 and enjoy free fees. And if people want to sell them on OpenSea, very easily they use the bridge. The bridge will mint the NFT on the fly. So at this point, they will bear the cost of minting the NFT, which is the same, more or less the same that they would have borne if the NFT had been minted on N1 in the beginning. Anyway, and they can sell it on OpenSea if they want. Anyway, so you can imagine a lot of stuff with that. Something cool is that you can design your bridge so that it's more liquidity efficient. So you can have your liquidity sit in a DeFi app if you want. You can imagine a bridge that is free to use, but that pays itself by classing the assets in this specific liquidity pool. You can really imagine a lot of things. And if you're not happy with the security of a bridge you want to use, you can design your own bridge with different security assumptions. Moving on. So the other thing I wanted to mention, which is really cool, is that it's a really tight L1 integration. The fact that you can move any kind of payload means two things. First of all, that you can really use L1 liquidity as StarkNet liquidity, which is crazy. I mean, in a way, you could go so far as to say that all the liquidity available in StarkNet is all the liquidity available in Ethereum. You just need to implement it, but you can use it natively and very easily. And the second thing is, like, if you think far enough, you could have a wallet on Ethereum that takes as parameters, that has a function that consumes message from StarkNet. And in these messages, you specify who you want this transaction to be sent to, what is the function it wants to call, and what is the payload associated with that. So you could really drive a wallet in kind of like a brainless mode on L1 and figure out how you want to drive this from L2. So anyway, that's a fun thing to think about and a fun brick to tinker with. And who is using it? I mentioned Maker earlier, who is exploring how to mint DAI on L2 using L1 liquidity. So they're going to operate their bridge, but soon enough, they're going to allow you to mint DAI on L2. That will be the same as DAI on L1 using liquidity on L1. And then Aave is exploring how to use DeFi pooling to port assets from L1 to L2. So Aave passed a proposal where they will implement Aave v3 on StarkNet, but in the meanwhile, they're exploring how you could do what we described earlier, meaning you could have a bridge where it's some kind of DeFi pooling where basically the assets you send to L2 are deposited in Aave, and so you get emitted directly on L2 AV tokens. Florian asked, I have not understood the part L1 liquidity, StarkNet liquidity. Can you explain again on how you would do this, please? What I mean is that since the liquidity is not deposited in one specific contract, in one specific bridge, you can design your app to tap directly into L1 liquidity, and you can design your app to fully drive the liquidity on L1. You don't have to rely on a token operated by someone else. You can design your own bridge, and so you can tap on liquidity directly. You don't need to rely on a bridge operated by StarkNet, by Starkware. And the second thing is that you can manage these assets and put them wherever you want. So they don't have to sit in a smart contract waiting to be withdrawn. They can move around and you can deposit them in DeFi protocols. So that's also something that's really cool. You know, when you're trying to bootstrap an ecosystem on L2, one big struggle is that, you know, you kind of need a source of yield for people to deposit money in your L2. But then this, but then basically bootstrapping this, like saying who's the first person to say, hey, deposit liquidity here, it's not very yieldy, but it'll get there, is hard. Here, you can really tap directly into L1 liquidity. And also, you know, DeFi apps on L1 have very deep pools and very good yields. You can tap directly into that from StarkNet. But I'm happy to talk more about this if it's needed. Antoine is saying the meme is completely accurate. I'm happy if this is interesting to you. All right, so I presented the content of today's workshop. Now, what do we do with that? You've understood it, right? Are you sure you understood it? How sure are you about this? This is today's tutorial. Fun thing, we started the GitHub organization, StarkNet Edu. My new colleague, Ben, who just joined us this week, opened it. So you can find all the tutorials we did last time here. I invite you to forward them from here because they're going to be the source of our repo. And this is, and I invite you to submit your PRs here because that's where we'll manage them from now on. And you can see in this tutorial, the messaging bridge, it's the same thing you're used to. It has an evaluator here that sits on L2 that will credit you points, but this one is different. It also has an L1 component. And if you go here in the L1 folder, you can see that there's some Solidity code with an evaluator. Pretty cool. So what is it that we want you to do in this tutorial? It's fairly easy. First, you're going to use the smart contracts to send messages between L1 and L2 and back. So you're going to send messages between them. You can use the contract we sent. You just need to find out which value to input at the right place. So you can play with the bridge immediately, figure out, and if you're too lazy, you don't have to write code. Now, if you're not lazy and you want to get points and you want to get swag because you did the first 3 tutorials, remember, if you manage to have 2/3 of the points for the 4 tutorials, you get free swag. Then you'll go further. And then we want you to do 2 things. The first step is for you to be able to send messages. So you'll write a smart contract in Cairo that sends messages to L1. And it needs to send it. It needs to be sent to a specific contract to unlock some kind of things that will credit you points on L2. And then you need to write a Solidity contract that will send a message to L2, unlock point, and grant you points. Then we want you to implement a message receiver, so a smart contract that is able to consume messages from L2 on L1, and a contract that has a L1 handler that receives messages from L1. Today's workshop was designed and created by Othman. Othman, I don't know if you're here, and if you can activate your mic and start talking.
Hello, everyone. I'm Othman. I'm a data scientist and also blockchain engineer. I've started learning Cairo with the Henri's tutorials. And today, with the help of Henri and Lieutaud, I wrote this tutorial. The goal of this tutorial is to understand the interaction between L2 and L1. So the goal of this tutorial is to understand the mechanism of messaging between layer 1 and layer 2. As Henri explained, there is 3 parts. The first part, no code needed. The first part is to send messages, and the last part is to receive messages. We will start with the first part, which doesn't need any coding. So let's start with our evaluator. We have an exercise 0 that allows us to mint some dummy tokens on layer 1 by sending a message from layer 2. As you can see, we have to do the exercise 0A, but let's see the code, I think, first. So the exercise 0, we want to send a message. This is what we have seen with the Henri's presentation to the dummy token address contract on layer 1 on Goerli testnet in order to mint dummy tokens. To do this, we have two parameters: the L1 user that will receive the tokens and the amount of tokens we want to mint. So here we will put our L1 user. Here we can put the amount of token we want to mint. For example,
Someone's feeling rich today.
so we send the transaction. But as Henri explained, when you send a message from layer 2 to layer 1, it takes time, approximately between 25 and 30 minutes to be accepted on layer 1. So we have prepared the message that we have sent. It's the same transaction before, so it's already accepted on layer 1, but it's not consumed yet.
Can you show the message tab on Voyager, please? Very nice.
Yes. And then we have the message. It's also the message. So here's the message that we have sent to the layer 1. We have sent our L1 user, the amount of token we want to mint, and a secret value, plus 32.
The secret value, you're using the same brick as the previous tutorials, right? For the people who did it, there's some kind of store on the L2 evaluator, and each user gets assigned a secret value. Is that it?
Yeah, that's it. You can see it here. Here we assign random value to each player, and then we send the secret value plus 32. It's like signature of Henri's tutorials. And we send the message to the dummy token on layer 1, and then, as Henri explained, when you send the message from layer 2 to layer 1, you need to consume it. It's not consumed automatically. So we will go to our dummy token on layer 1. This is the contract.
Hey, do you think before consuming the message, you could show us the StarkNet contracts on Goerli and we can see the counter there?
Yes.
Cool. Thank you.
What you can see is, this is the proxy. And when you send a message from layer 1, from layer 2 to layer 1, it passes by the StarkNet proxy. And here, if you have the message hash, you can see the counter. We already have our message, it's here. We have our message hash. So we put it here on the proxy. And yes, we have one message that it's waiting to be consumed. So now, back to our dummy token. We want to mint our token. Let's have a look at our code of the dummy token. So in order to mint the dummy token, we need to send the secret value and the amount that you have sent. Because when you want to consume a message, the payload needs to be the same. The L1 user, it's our user, so it's the same. the amount need to be the same and the secret value need to be the same. So here we have our message here. We have this amount, put it here. Our security value, it's this one. Then with some transaction.
Didn't you have to do something with the 32?
Sorry?
Didn't you have to do something with the 32?
No, it's coming.
Okay.
Because yeah, just to explain that, here you see we have sent the message with security value plus 32. So what we need is to give it here the security value plus 32. And after we'll see where this plus 32.
So here, this is yet again an example that things are not private on StarkNet, right? Even if secret value plus 32 was sent, you could look at this contract storage and have secret value, but you went into Voyager and saw directly secret value plus 32. So yeah, I just wanted to mention that.
Yes. So here our transaction have passed. So we have consumed the message and we minted the tokens with this value. So normally now we have the tokens. We can also be sure add it on MetaMask. Yeah, I have the tokens now. What we have to do is to call I have tokens on layer 1 to show that we have minted the tokens, and this one will send the message to our L2 evaluator and trigger automatically the point distribution of this exercise. So now we need to show that we have the tokens. We need to give it our L2 user that will receive the points of this exercise.
So here you put it in hexadecimal or in uint256?
Etherscan, it converts it automatically.
Cool.
And here we have to put the real secret value, because if you see in the code here, the I have tokens will send a message to this function in order to validate and distribute the points of the exercise. But we need to have the real secret value that was stored here, which is our secret value in the message minus 32. So where is our secret value? It's here. Minus 32, it's 5. Then we send transaction. The transaction normally it will send the message to the layer 2. We don't have to do any action because it's different. We don't have to consume it. It's consumed automatically. And there is a selector on the parameters of.
How do you calculate the selector?
Yes. There is a Python script that you can use easily, and there is a function which is get selector from contract, and you give from name, I think.
I think the selector right now, the selector is the hash of the function name. It doesn't take into account the parameters or things like that. This may change in the future, but right now that's this. But there are some utils that allow you to derive it from the function name, basically.
Yes. And as you see, the I have tokens function, it will see if you have the tokens, you have minted the tokens, then it will send a message to layer 2 with security value L2 user. and there is this claim selector, that is the hash of the name of the function. And once, just see, click this one. This is the transaction. You can see here that a message was logged to layer 2. We can go back to our contract. And normally you can see that normally a message will be coming from the layer 1. It will take a little bit of time, maybe 3 or 5 minutes.
So how do you debug when your message is fucked? Does it appear here? Like if your message is wrong, does it appear here or not?
The message appear, but it will appear, and for example, see, I think this is the message. This message has been received, but it's on sent. If it's the wrong message, it won't be consumed. If it's a good message, it will be consumed. But if it's not the good one, you won't have the transaction. If it's the good one, you will have consumed, and you will have here in L2 informations, you will have the transaction hash. So we'll just wait a minute so the message can be consumed, and we can also check if we have received the points. By adding check. Yeah, we will wait for the point to be distributed. But yeah, if it's if the message is wrong, you don't have any way to debug it. You have to figure out.
What's the issue?
Yes.
Yeah, we definitely need better tooling around that. Pretty cool. So while we wait, I wanted to mention that Othman, you'll be in Amsterdam, right? For the hackathon?
Yeah, that's it. I'll be in Amsterdam, looking to build some cool stuffs there. And
so if you guys are in Amsterdam and looking for teammates, here I'm putting it in the chat. Here's the nickname of Othman in our Discord. Do reach out to him.
yes.
Yeah.
Maybe I have done.
Yeah, I was wondering because I think I saw 85 and you put 55. Did you subtract 32 or 37 or 30?
32.
No, you subtracted
It was
32.
87. 87.
Okay, so it should be good.
Yes.
It should be. Here's something that would, it's not perfect, but something that would help is, you know, can you show your L1 handler?
L1 handler?
Yeah. Basically here, your L1 handler.
This one?
No,
Okay.
on Cairo. See the check that it does, right? You could put it into an internal function, and you could have an external function that is a mirror of x0b of the L1 handler. And so people could call it and see it returns a 0 or 1 if the function will pass or not. That way people can say, hey, so I'm going to replicate the payload that is being sent from L1 and see if the call will work.
Yes.
Does that make sense? That's a hack, but it could work.
You can also see in our contract if the exercise was validated. So our account here.
Also wanted to mention that Florian, who did the ERC20 token tutorial, will also be in Amsterdam, and here is
It's not yet.
username too.
Sometimes it takes a little bit of time to be.
That's the demo effect. How does it feel, Othman? You're in front of 160 people. No, but all good. I'm amazed about what you built. Thank you a lot for your
Thank
help on
you.
that. To be honest, building education tools around StarkNet and raising awareness about all of this is not an easy feat, and I'm very grateful and humble to have people collaborating with us on that. If some of you are interested in building, tutorials or content, do reach out. I'll be happy to talk with you and see how we can make things work.
We can show you a message that has been consumed. Here, for example, when the message is consumed, you will have here consumed, and you will have the transaction hash and you can see your transaction on layer 2.
So this transaction was executed by the sequencer, right? And it basically it was executed by the sequencer, and it called your L1 handler.
That's it. It's a message sent from layer 1 that trigger automatically based on this selector function on your smart contract with the payload.
Cool. Can you show me your transaction on Etherscan, the one that triggered the L1 to L2 message?
Yes, here is it.
How many confirmation does it have?
See, 4 block confirmations.
Can you refresh it?
Yeah, 32.
32. Okay, so the message should be going through. I think if I recall correctly, it should be 10 block confirmation, but sometimes things need to pick up.
Yes, and also sometimes Voyager
lags a bit.
Yes. Yeah.
Okay. So what do you say we wrap it up? And I think if you have more questions in the chat, feel free to ask them now. Otherwise, I think we're on time. We spent about an hour there. As usual with our tutorials, we don't focus on people who want to cheat. You probably thought that to yourself, well, I mean, I could take the L1 pool, the L1 token, and put them in Uniswap, and then people could buy them and validate the exercise without actually sending a message to L1. And you're absolutely right. But we don't optimize for cheaters. We optimize for people who want to learn stuff. And this tutorial will take you a bit of time. It will take you a bit of time because, you'll have to figure out how to use this. You'll also have to figure out, there's a delay in communication. So I highly suggest that you read the whole scope of what we expect from you, and then you figure out how you can optimize your time. Probably what you want to do is first try to code or answer the questions that require L1 to L2 messages so that you send a bunch of them, and then you start working on the other exercises, so that by the time you finish with those exercises, you can go back to see your answers to the other one. Also, this tutorial is not like the other one. It's not like you're going to spend 3 or 5 hours and be done with it. You'll probably have to spend an hour here, an hour there to let time for messages to go through. So it's a bit of a different one, but it's a bit of a different tool. So basically that's it. Let's wrap it up. Thanks again, Othman, for your intervention. And everyone, I think this was our last workshop. We have one more in 2 weeks with Matchbox DAO. They are going to be presenting a really cool thing too, which is very specific to StarkNet too. They will show you the kind of thing you can do when you have more power of calculation than on Ethereum. And specifically, they're going to show you things that if you like video games or you can use it for a lot of stuff, but for video games, they're going to show you something you'll enjoy. So be sure to be there at that point. And don't hesitate to reach out if you have trouble with the workshop. Don't hesitate to reach out when you finish the workshop. I'm waiting for you, really. And if you need ideas or help for the hackathon, for the submission, don't hesitate and reach out also. I'm happy to talk and give you ideas or opinion. I think ideas for StarkNet are a dime a dozen. Now, I mean, like implementing and going forward with the project is the hard part. So get to work, and I'm looking forward to see your contribution.
Perfect. Thanks so much, Henri. Thanks, Othman, as well for the tutorial. But yeah, I think just really to StarkNet, thank you so much for being fabulous partners. Obviously, we've still got another workshop to go, and a little bit of judging, and hopefully some good prizes to give up. But Henri, it's been an absolute pleasure having you on all the workshops. I've really enjoyed it, and I've got no technical background, so I can't imagine how much the devs out there have enjoyed it. So yeah, thank you so much. And yeah, thanks so much everyone for coming and being so engaging. It really has been a wonderful couple of weeks. Yeah, so chat to me on Discord, chat to Henri, chat to Othman. We're all here to help you out. So thanks so much, guys. Have a good day.